So I'll show an example for this. Then we'll jump into the mean. So as I told that if you get a um, cumulative frequency lower class boundary based problem statement, so all these intervals are piecewise linear. So we are going to use that property here. So assuming the marks basically you are getting, marks are nothing but the lower class boundary here. So basically we piece of a problem and we are getting the class cumulative frequencies with the less than type. So this table is given to us. So it is like 7, 4, 8, 4, 5, 6, 5, 60, 511 and 65 got 514. So this is a marks of few people on a class along with the cumulative frequency of the lower class type. So I can assume this as a, I mean, by default we generally give the lower class boundary of the numbers. So this is the number distributions we got. So they're asking us to find out the number of candidates whose marks lie between 48 and 62. Right? So 48 and 62, I need to find out how many students are there in between 48 and 62. So now observe this 48 numbers comes in between this and this interval, right? And 62 comes into this particular interval, right? So if I find out, suppose 48 corresponding to that value is coming as say I am telling this is a y1. I'm taking this column as x, this column as y. You can take the other way also. There is no problem. So this is a y1, and if 62 is coming here, so if I find out this as a y2, then that means that if I find out the y1, that will tell me that below 48, this mean number of students are there. That is the less than time mean, right? Below 48, this amount of students are there. And for this particular case, y2 will be there. The below 62, this mean number of students are there. So if I minus this y2 minus, of course y2 should be higher. If I find out this y2 minus y1, that particular interval is going to give me that how many students are there in between this 48 to 62. But please make sure this 48 interval is different, 62 interval is different. This, as I told, in between this is piecewise linear, in between this is piecewise linear, and so on. So I cannot take the same slope for every case. This is the different slope, this is different slope, this is different slope, and so on. This is different slope. So for this case, I have to take care about this particular uh, area, and then I have to find out. So if I just find out for given number, as I told, first I will find out in terms of y2 minus y1, whatever given is there. So I will take, for the first case, I will take this as a y2, this is a y1, this is a y1, and x2, x1, right? So that means I go to 484 minus 447, y2 minus y1, corresponding x. 484 corresponding x is 50, 50 minus 48. That is the slope. Now I'll use the same formula. Now the y2 will just change. Now y2 will become my unknown value, that is the y1. y1 minus the lower cumulative frequency, that is 447. Corresponding y1 corresponding my class lower class band boundary is 48 minus 45. Like this, simple. Just compute the same uh, slopes. You should get the value. So if you calculate this, you should get something like 469.2. Of course, your frequency cannot be point value. So if it is below zero point 0.5, make sure you discard this. If you are getting above 0.5 or zero point 0.5, you can take the next frequency. Similarly, for the same case will happen again in between 60 to 65. Again, you got the piecewise linear. So again, I'll use the same process. So this time 514 would be my new y2. I11 is the y1 corresponding x51 for corresponding x1 is 65 and I11 corresponding is 60. In this case, now y2 will change. Now unknown is the new y2 minus y1 divided by 62 corresponding x2 is 6. Sorry, y2 corresponding unknown is 62 minus 60. Right, so this is y1, the y2. Again, if you solve this, it will become as a 512 or some point two something. Again, as I discard this point 2. So 512 itself. Now, if I just do y2 minus y1, it will become 43. So let's check the equation from point numbers. Go here and there. So eventually, this is the 43 number of students should be there in between this 62 and 48. So that's how basically we can use this particular formula, and we use this particular concept when we calculate the median and the mode, not mode mostly, median and the quartile. Okay, we'll come back there. Okay, now so this is the basics of the our understanding of table, understanding of the basic words. What are the boundary? What are the class limit? What are the relative frequency? What are the equivalent frequency? All these things we understood. What is the cumulative frequency? That things we have understood. Now we'll start with our very basic things, that is the mean, right? So first of our descriptive statistics, method of central tendency. If I just make a table, so method of central tendency basically divided mean, median, and the mode. And as you know, mean also are of three types. Sorry, three types. One is arithmetic mean, short form is AM, geometric mean, short form is GM, harmonic mean, short form is HM, right? Median model are there. So method of central tendency, that means that how much centrally your data is can be represent in terms of the descriptive statistics. That's what these three things can try to give you. In terms of means, how what is the central data? Typically, of central data or representative central data, it can be. Of course, it has three types depending on the limitations of each and every kind of means. When the median, the middle value, specifically the middle value itself, and the mode, the most used value into the set of the values. Of course, we have having a basic idea about in terms of the ungrouped data. So, but let's try to take this concept in terms of the say some complex data or the frequency table data. If I have frequency table data, how can I deal with this in terms of mean, median, mode, and the different types of mean? So very basics. That is the first. Will of course for the each and every case mean. So I'll start with the arithmetic mean. So nothing much to talk about in terms of the understanding of the mean. So I'll give the basic idea, basic equation for the mean, and then give the example of the mean. At the end of the day, end of the plot, I'll explain. I'll compare something in terms of the numbers. So arithmetic mean would be two types. One is something is called a simple. Simple means that these numbers are there is no frequency as such in this particular part. So we generally show the arithmetic mean by x bar. X is a variable. If the x is a variable and x is taking value of x1, x2 to xn, so n is the number of the values. So x bar can be represented by 1 by n summation I1 to n of xi. Eventually there is nothing but x1 plus. If I take the I as a 1, 2, 3, 4 like this till the xn divided by number of observations, that is the simple mean. If I take a simple example, so I keep this number same to show some observation. So it will be say if I take the value 8, 1, 6, so my observation would be 8 plus 1 plus 6 by 3, that is 15 by 3 is 5. Right? So three numbers, it is giving me summation of all the numbers taken by the observations. Eventually, it is giving me the number. Right? Now, this is simple that I told. Now, what about the weighted? Weighted mean. Right? Weighted means for the x, each and every variable x is connected to a frequency. Okay. Initially, I'm showing as if this is an ungrouped data, but eventually, for a group data also, we'll solve a problem. We'll see that how to deal with the group data to ungroup data. We'll do that. So suppose for this case, x1 with a frequency f1, x2 to the frequency of f2, so eventually xn with the frequency of fn. The equation looks something like this: 1 by capital N summation 1 to small n phi into xi, where your n is nothing but summation of all the frequencies. So x1 to xn with the respective frequencies f1 to fn, x bar should be 1 by capital N, or you can write a straightforward 1 by summation of a phi, that is a summation of all the frequencies, summation of I1 to n, a phi multiplied by xi. Simple. Now let's take an example. X if a to 1 6. So now put the frequency 5. So the calculation would be e plus 2 plus 5 summation of the f, the 3 multiplied by 8, 1 multiplied by 2 plus 6 multiplied by 5. If you solve this, I think it should come as a 56 by 10. So it should be 5.6. So you got two numbers. Let's keep these numbers. Do some observation later. So what a standard arithmetic mean? Of course, you know the application of these things, like find out the sales, find out the standard profit, find out the sum average of this number. So this is the standard way to find out all these application of the arithmetic mean. Now the problem came in the terms of that. Suppose in this particular part, in this particular example, if I would have put the one frequency quite high. So suppose for the 6 frequency, I put a 5 as a 5,000. Instead of 5, I put 10,000. So of course, the numbers you can assume that it will go towards the 6 as always, as a normal mathematics says. So if this is a non kind of a balanced frequency, if you find out, or the non-balanced number is there, anyway, non-balanced number is quite a logical. If the one subset of number is quite high, of course, the numbers should go to the towards that. But if it is a quite frequency or quite imbalance, that eventually can gives you the wrong descriptive number, which that particular number is not actually there in that set of numbers. Suppose in a particular class, almost half the students are getting say quite a low marks, and quite a huge number of students are getting a huge marks, and it is a quite a linear types of frequency distribution. The respective number will come in between somewhere, so which does not show you the actual scenario of what is actually happening in that particular case. So that could be a limitation for this arithmetic mean. In that particular scenario, if we have, in addition to that, suppose if I have a kind of a cumulative kind of scenario, like first order number is input to the second order number, second year number. If that is a scenario, then this since of course it is a it's quite lengthy, it can be quite lengthy. So for that to solve that kind of cases, we generally come up with the second type of mean, that is something is called the geometric mean. So geometric mean, so generally we do not do that much in terms of the geometric mean, but okay. So just let's see the quick formula. Mean for the two times. That is a simple formula, simple geometric mean. The geometric mean again I am showing this as a generally we show as a small g. It is nothing but the root of king root of basically x1 multiplied by x2 is a multiplied by xn. Okay. So number of observations is here, and you're multiplying all the numbers and root of that number. Of course, as from the equation itself, we can see that this is quite a computational heavy. That is there's a limitation for this kind of a mean. So say if I put the numbers, the standard number, the numbers what we are generally taking, that is x was taking the value 816. So the g should be, since the observation is 3, so it will be root of 3, 8 into 1 into 6. You solve this, it will become 3.63. Now, of course, you might ask, like, if I don't have a, which is quite a, if it is a huge number, how should I deal with this kind of a number? Of course, right? So, of course, as you know, we have this kind of options. So, what we use basically, you can write this equation in terms of like this, right? So you can take a log, right? Both sides you can take a log, which can help us. Log 10 is quite good enough. So 1 by n log of x1 multiplied by x2 to xn, and like we can solve this log number. Log is, I mean, if I multiply this, that means this is nothing but the log of x1 plus log of x2. So we are trying to make the computational heavy concepts to a computational easy concepts actually. So if I got this number, so eventually see that this is coming as a, some number a is coming. So you can take the antilla, or you can take, if it is a 10 base, you can take 10 to the power e. So eventually this will give me the final answer. It is also one way to find out our this case. Same thing, of course, we can use for the weighted case. Let's see that, okay, how should I deal with the weighted case? So if I take the weighted frequency, that is x and f, x1 taking frequency f1, x2 taking frequency f2, and so on. So in that case, things a little bit more complicated, because if say m is f1 plus f2 to fn, that again same thing as a summation of I1 to n fi. So your this is come as a capital G, your weighted GM, generally given as a capital G. So it is x1 to the power f1, 1 by capital N square root of not square root of x1 to the power f1, x2 to the power f2, and till the xn to the power fn. More complicated in terms of the calculation process. Even if I just take a log of this, so in the right like this again, we know capital 1 by n is nothing but a summation of all the frequencies. So G would become 1 by n f1 log x1 plus f2. I just made a step jump. Hope it is fine for you. Log of xn. Right? So this is the way when you can find out the numbers. Same process. Get numbers a some a1 g would be 10 to the power of that particular number a1. That's how you need to find out the weighted weighted g. So again, the standard numbers what I have taken the last example. Let's take the same numbers. So if I take the x and f it 1 6 with the frequency 3 to 5. So capital G in this case should be, let's find out 3 plus 2 plus 5 is 10. So root of 10 8 cube multiplied by 1 square multiplied by 6 to the power 5. There is a quite common chances to put x to the power f to f to the power x. So do not took a mistake there. So q transfer and this is a huge number. It will come as something like root 10 of 398131 or something like this number will come. You can check this number. And if you root this, it will come as a 4.5. So you can also use the scientific calculator, or you can use the log versions of that. As I could show you the log versions of this, so you can find out that way. So again, same numbers, same frequencies, we got different numbers, right? So for the AM also we had shown something different. For GM also same numbers, we got two numbers. So we put these numbers later. So this is the more or less the GM of this. So if I talk about in terms of the GM same applications. So as you know that for any kind of compound interest, compound cases, if you know, so first year if this is the number, second year you're getting some set of ratios. So what would be the final average of the ratios? There you generally use the GM. We will do a problem later after the EM will do a problem. So probably we can see that few examples of GM also, one or two examples of GM also in this, like in that particular part. I'm just finally first finish the theoretical part of this, then we'll go to the example part of that. So this is the second part. So this here is a compound situation. As I told you, the first year input is going to the input for the second year. So that's kind of scenario. If you want to find out the average rate, average, say some kind of bank rate or something, as a the compound or interest or something like that. For that cases, you need to use this geometric mean. Of course, the limitation for this particular is mean is it is quite computational heavy, and you need a lot of calculations of it. Third part is that ratio types. If you have some kind of a ratio types like the average speed, average people capital, or something like that. So this kind of cases, if you have ratio type situations is there, then CPC probably. Those cases, if you have, then you go for the third type of calculation, that is something is called the harmonic mean. So probably very from a very childhood you have find out the average speed, the and kind of things. We use the harmonic mean. So harmonic mean again two types. One is simple without any frequency. We call it a small h. So the formula for this would be summation of 1 to n 1 by x. The variable is now 1 by x. So in number of observation divided by summation I 1 to n 1 by x. Right? And if you, it's quite easy to calculate. Normal simple calculus can help you. So again, the same numbers I'm going to take x816. So small h should be number of observation is 3, 1 by 8 plus 1 by 1 plus 1 by 6. If simplify, it will become 2.32. Correct. So this is a simple harmonic mean for the weighted, the harmonic mean generally shows a capital H. It is capital N divided by summation of I1 to N if I by X. Right? This is a quick formula. Again, capital N is standard summation of I1 to N if I. Perfect. So again, I've created the same example 8, 1, 6, 3, 2, 5. Alright, so if I find out the values in terms of this, 3 plus 2 plus 5, we got f is 3 by 8, 2 by 1, Just make sure you are writing fi by xi, not the xi by fi. So 5 by 6, right? So this is if you solve this again, 3.12. So see, we took the same numbers for all the examples, right? So if I just write this in terms of the simple weightage, so in terms of AM, GM, and HM, see the numbers how it is come. So for the simple weighted, we got the number as a 5 and 5.6. GM, same numbers we got 3.63 and 4.57. And finally here we got as 2.32 and 3.12. For each case, we will see that this number is greater than this number is greater than this number. For the simple case also, weighted case also, both the cases it happens. For if you take any number, of course, any number, any observations of the same should be on the all over the cases. It had been found that AM would be always greater than GM, always would be greater than HM. So this is quite a fix for any scenario. Okay. So this stays for any number, any problems, any cases happens. I'll just show you quickly that this always happens in terms of AM and GM. Just a small little algebraic way to show this thing. That is, suppose somebody asks you like, can you show like for say two numbers, any two numbers A and B, which are non-negative numbers, typically suppose two self number, something like that, positive numbers. Can you show that AM is greater than always greater than is equal to GM? How can I show that? Only using a very basic statistics. So in that kind of a problem, always start with the definition. So what is the aim? Aim for these two numbers should be what? How much? Should be a plus b by 2, right? GM should be how much? GM should be square root of AB, right? So I have to show that somehow a plus b by 2 is always greater than equal to root over of AB. That is the whatever I have to show. Of course, one thing is that always can start with this assumption, okay, this actually happened, this actually holds. And some point of time, I can tell that, okay, since this particular line happens, then our assumption is true. Like that way, I can tell that. Okay, so let's try it that way. Say, assume that this always happens. Let's say. So some line I have to go there where that I have to show that, okay, this happens always. That means this also happens. So how can I write? So simple way, a very basic algebra. So you can see that what is the pattern on the side. So this should be like this. So again, so from there a plus b minus root to ab should be greater than equal to 0. Now what is this? This is nothing but if I say square root of a whole square root of b whole square minus 2 of root a multiplied by 2 of root b is 0. That means nothing but root a minus root b greater than equal to 0. Now this is a quite a obvious case. If these are two real numbers, minus or whatever of the square of the number should be 0, and not it cannot be negative number as such. So square of the number should be positive and it should be greater than or is equal to 0. So since this particular line always holds, that means that our assumption from there we have started that also always holds, right? So that is the kind of a very basic way to show that, okay, this is the process how we can show the AM and GM things. And now about, let's start with the arithmetic mean with the frequency, right? So I mean, of course, we always know that arithmetic mean with the normal arithmetic mean just put the number, add the number, divide the numbers. So that is quite a easy way to do any kind of a number. So that is there is nothing much out there. So we can just a second. This before I think I was admitting me. I mean there is nothing much as such to do here. So how about I just show you few examples of GMNH? That would be very nice. Then GMNH, I mean, like in the mean, I mean it's obvious, so that I mean, like nothing as such to show there. So probably when we will do the other things like standard deviation and all there, we'll do the mean anyway. So let's do this for the. Let's see some examples in the terms of the um, GM nature. So on to examples that would be good enough to understand. So say example for GM one, one for GM, that is a investor and the following returns. Say the here is you got the returns, right? So first year return you got this, second return is this, third year return is this. So first year return 12%, second year is 8%, and third year is 15%. So find out the average annual return. In this kind of a problem, of course, this basics of these numbers are different, right? So just cannot add the simple two now three numbers and find out the return that will be going to be useful, because as I told, the inputs probably this input is going that another input is going to the third. Is it inputs, right? So you cannot, if you do that, you will give a low number. So for this kind of problem, of course, for the first since it's the percentage numbers, I cannot deal with the percentage number. So I'm assuming that the initial numbers are 100. So first it is the since it is a 12% increase, that is I can take this 1.12. So like one is the initial number, so 1.12. Second year it is 1.08, and the third year it should be 1.15. Of course, if you get some negative numbers, so that is a minus 15%. So it will be minus sorry, it will be 0.95 like that. It will work like that way. Okay. So initially, assuming the one is the very basic, so I found out the returns for these 3 years. Now, if I want to find out the annual average for this case, so I'll do the GM for all these numbers. Actually, you should get something like 1.1163. So then I can find out the average return as, so 1.1163 minus 1 divided by 100, so 11.63%. This is the average return. So I think there is that this is for the 1 year average return is for each and every year. Suppose now somebody told you, okay, so suppose initially I have started with the input of say 5,000 rupees or something like that. So then what should be a third year? So you have to multiply this with 3 times 5,000 with 3 times. You have to do this particular calculation. So then you will get the final answer. And if you do the step by step calculation also, you will get the will reach to the same number. So if it is a non-weighted situation, simple GM situation, this would be the one process to deal with the problem. What about the weighted part? So the weighted example could be something like this. A company sells three product categories. Here annual growth rates and revenue contributions are as follows. Say product is product growth rate, third one is the revenue, so revenue share basically, and this is the growth rate factor. Let me talk about this. So let me write growth factor. Like as I told you, we do not deal with the percentage. That's why I need that. So write this electronics clothing furniture 20%, percent, 5%, 30, 20. Right? So in this particular case, first thing of course always understand which one is the your x value, the variable, and which one is the frequency value. In this case, this rate part is your x value. So this is the not exact because as I told you, percentage is there. We cannot deal with the percentage. Of course, I have to take this growth rate as a growth factors. That is a new x would be that is 1.12 like the previous one, 1.1 and 5% 1.05. This is the x value. This revenue share that is the my frequency, right? So always understand which one is your frequency and which one is your variable. So easier to understand obviously the growth rate, all this kind of rate, that kind of rate, these kind of numbers would be your x value, okay? And this share, that much share, that would be the frequency. So this is now we have identified this is a now x value, this is the frequency value. Now if I want to find out the average, I have to use the of course the frequency formula that is weighted GM. So typically I can write like 1.12 to the power 50 multiplied by 1.1 to the power 30 multiplied 1.05 to the power 20 by 100, 30, 50 plus 30 plus 20, like that. Of course, now how you solve this, it is up to you. You can quickly put in a computer and solve this, or you code it, or you just divide this in terms of the logs and you solve that. That is up to you. So I guess finally it should be something like is 1.1383, something like this. And so the growth would be 0.1383 minus 1 multiplied by 100%. It is nothing but the 13.83%. So this is the typically GM example, right? And so two problems for the GMs. Now let's go for two problems in terms of the HM. Process customer orders at different rates during the day, right? So how they do this? So time period and the processing rate, that is say orders plus hours. That's how they find out. So for the morning section, the rate is 120. Afternoon section, it is 180, and the evening section, it is 90. Right? Then of course, each periods lasts 4 hours, and the average processing rates. Right? That's how we need to find out. So in this case, if you see the average of the rates as a that if it is not compound, like unlike the other types, your basic, because these numbers are not the percentage numbers, right? So these are the um, orders per hour, this something per hour, part something kind of things are there. So that case scenario, we generally goes for the agent, the harmonic mean, right? So of course, this has nothing to do with the actual calculation, but it is always good to know the how much hours. Like you can do the other question also. So HM would be for this case like number of observation divided by number of variables. Straightforward. Straightforward. You can use the formula and find out the how many storage orders you can go for. 120 orders per hour. This is the average for that. Of course, do not go again. Do not if we put as a rate, do not go for the arithmetic mean. It will give you the more numbers, more uh, values in that particular part. This is for the simple HM. How about the weighted HM? So same page. Similar case for the weighted example. So factory produces on 3 machines. Say machine, the machine numbers are there. So 3 machines are there. So machine is there. Units produced, and third one is the production rate. Right? Production rate. That is also unit per hour. Right? So these numbers are there. So say machine A, machine B, and machine C is there. First one is like 1,000 is producing 1,000. Second one is producing 1,500, and third one is the 1,000, 2,000. And the units per hour. This one is for 50. This is for 75. This is what 100. Okay. So again, for this case, if you want to find out the overall production rate and overall production rate, if you want to find out, of course, first option would be to find out which one is the variable, which one is the frequency. As I told, same logic comes here also. Like if you find out the unit per hour, something like this, always find out that as the your value of x, and number of production of that particular x, that would be the frequency value. So this case, this would be the frequency values. So again, rate wherever you find out the words, that is the simplest way to find out. That is, this is the your variable, and other things would be your frequency. So again, if I use the weighted harmonic mean formula, if you remember, summation of the f should be in the top, 1,000, 1,500 plus 2,000 would be the on this, and below it would be summation of fi by xi, right? So summation of fi by xi. So first the frequency will come 1,000, by x value will come 1500 by 75 will come, and the 100 2000 divided by 100 will come. So again, if you solve, this is quite easy to solve. So I think it will come as a 75 unit per hour. Right? So this is the simplest way to find out your GM and HM. So of course, this is not much of our applicative way to use these things, because I understand until you are working on the financial data. Of course, in financial data, suppose if you are doing any kind of KPI revenue, so these cases, if you want to find out, that is the simplest, you go for the EM, right? For the suppose growth rate, ROI, CAGR, if you are dealing with this kind of numbers, we are going for the GM. And for find out the speed, production rate, throughput, CPC, cost per lead, price per unit, response time. If you are dealing with this kind of numbers, of course, then if finding out average, of course, so in this kind of number, then you should go for the harmonic mean. Right? So these are the very basics about the GM and the HM. So that is the GM and the HM. For the aim section, let's can we go for the aim? Just okay. Uh, Even of course, the number wise, we don't always know, just multiply the frequency in all these cases. We do this aim or not explicitly showing you the examples in terms of the aim, because in when later part projects of the things we are going to discuss about the aim part. So let's not explicitly do the aim calculation. So from next part we go for the GM and the HM. All these cases, when we go for that part, we have to calculate all those things there. So not showing the aim explicitly. But coming back to the this other discussion in terms of the aim, but also this is also true for the GM or HM also. But we get to discuss two very important properties about the mean, specifically for the arithmetic mean, and we keep on discussing that two properties for the rest of the other our descriptive statistics part, that is for the for same also, for variance, for correlation, for regression also, we keep on addressing that two properties. That is something is called the change of origin and change of scale, right? So the thing is that when we used to calculate manually for these cases, so you got a huge a big number of data, right? So it is quite tough to handle the big numbers in that particular scenario, and you got to still now do the calculations by hand. It is very tough that you cannot calculate using the, suppose you got say 2000, 5000, 2622, something like this kind of odd numbers will be there. It is very tough to calculate in terms of manual. Right? So what we do is that we change the numbers. So in terms of, if you change the change of origin, that means that if I define another variable, suppose x is our original variable, we can do a minus, right? So x minus c. So c is some constant. This is let c or d or a or b, something to that, nothing but the constant value. So this thing is called the change of the origin, and the change of the scale is basically nothing but the y is equal to x by say d. Right? Can be multiplication. This can be plus also. So that is assignment of the symbol is not important. So like it can be x plus c, it can be x minus c. Y can be y divided by d, it can be y multiplied by d. C and d both are constant value. Okay. So if this happens, of course, we can reduce this big number, so say x as quite a big number, to a small number, which we can calculate quite easily. Even if you do the manual calculations, you will see that this is going to help you a lot. So if this happens, if these two cases happens, what will happen to the mean? That is the main question. Suppose if I know that if the set of value x, the set of value, it has a mean of x bar. Now, if I define something like this, y is equal to x minus c, then what will happen, right? So for this case, of course, quite simple way. I'm just, since it is a quite small derivation, I'm just showing you y bar taken. It should be nothing but the summation of I 1 to n of yi, right? So since y minus y bar into x minus c, that means that I can replace this variable in terms of xi minus c. C is a constant, so there is no change in terms of I values. Only the variable is going to change in terms of the I value. So eventually that means that corresponding to the each yi, corresponding to each xi, I got a yi. X1 is the sum of corresponding to the y1, x2 corresponding to the y2, similarly xn is corresponding to the yn. Like that way, it is connected, right? So that's how basically I can put these numbers. Now, if I this kind of scenario comes, I can put this summation value to both the case, both the numbers out or whatever is there. So I can write 1 by n summation of I 1 to n of xi minus summation 1 by n summation of c. This case I cannot do anything. This is let it be like this. Of course, I know what is the meaning of this. This is nothing but the x bar, right? So I can write at this. This is x bar. Whatever will happen to this particular scenario, that means that you are adding the c constant for n times. That is nothing but the c plus c plus still the n times we are adding the c, right? So if you add a constant n times, what is the meaning? This is multiplied by n, right? So if you add one n times, what is the value? N. Similarly, it is we are adding the n c n times, so it is n into c divided by n is already there, so divided it is x bar minus c. So if I do y is equal to x minus c, that means that it will be x bar minus c. If I know the mean of the one value, I can find the mean of the value. Usually, suppose if I just change in the origin, I get a new variable y. I found out the mean of the y, so y bar. I got the y bar. I got the y bar. I know the c value, how much I minus plus whatever I did here. I know, of course, the value of the constant value. So if I add that or minus that from that case, I can find out the x bar. That is simply moral of the story. Similarly, if you do the same process and put the yi by d, of course, you can find out y bar would be x bar divided by d. Okay. Same. So basically, these two properties, this change of origin and change of scale, we will keep on doing for the next of our few, as I told, the few cases. We'll show that this also happens. Right. So let's take an example, and that could be our last discussion. Is that let's take an same numbers what from where we have started the table and try to find out or understand that how the aim is generally done using this change of origin and change of scale. So in a same example, we will do the two things together. So first thing, as I just repeat the first problem, class interval with 15 to 19, 20 to 24. I need to have a lot of space in the right hand side. That's why I'm writing like this: 25 to 29, 30 to 34, 35 to 44, 45 to 59. With the respective frequencies, already have given this 37, 41, 43, 24, 9, and 6. So this is already given. Now the new things we are starting. So and things that always start with the find out the class part or the mid value, whatever you want to say, this class mark for the representative value for the any class intervals. For this case, you do not need to find out the class boundary. Okay, so find out the class mark. So as we have found out lower plus mid plus upper plus mid by 2, 15 plus 19 by 2. Like this, let's write down all the class mark. for each of the group or class. And good enough. Now, once you got the class marks, then of course, typically what should I do? I should, for this frequency case, I should add this frequency that will give me the summation of the frequencies. That is 200 anyway, that is needed, so I can find out. Second would be so 1 by n summation of fi into xi, right? There is a formula. So I should multiply 17 multiplied by 37, 22 multiplied by 81, 27 multiplied by 43. Like this, I have to add, then I have to do the calculation. But of course, as you can see, numbers are quite big. I do not want to deal with this kind of a big numbers. And say I forgot the calculation, light is off, everything is done, but I need to calculate this. How should I do? So I am going to use this two formula, that is the change of scale and change of origin. I'm going to club these two. So let's define first x minus. So of course, since it is a kind of a sequential data, higher to lower to higher, either way, I can do one thing quite simple. That is, I can choose the median value of this particular numbers. Here you got 6 numbers. You can choose either 27 or 32. I am choosing 27. Either way, you can choose 32 also. Answer will be same. So of course, the other numbers will be different, but the answer will be same. So 32. Let's take the 27 as the number. What will happen if I take the 27? So you can see that is a quite a homogeneous kind of calculations up there. So if I just write like this, because this is not the final numbers, so I'm just that's why dividing this. It will become a minus 10. This is minus 5. This is 0. At least one number I did not to calculate. 43 minus 0. So to add one part would be 0. 5. This is 12.5, and this is 25. Right. So that much I can do minimizations in terms of the using the change of origin. So what if I add the change of scale here? Because at least from these numbers I can find out the pattern. If there is some 5 is there. If I divide this number by 5, I can further reduce these numbers. So if I do this, it become a minus 2, minus 1, 0, 1, 2.5. Now it is quite easy numbers, to calculate. So I can now take, this is my new variable, this number. So just forget about these numbers, just to show you I have done this. So this is my new y variable, which is x minus 27 by 5. This is my change of scale and change of origin gives me. So eventually I got a quite small number. Now I can multiply this y if into y numbers. So basically this multiplied by these numbers. So minus 2 multiplied by 37, like this way. I have to find out, of course, 74 minus 81, 0, 1, which I have to do. This is 24. This is 22.5. This is 30. Okay? So I got fi into yi. So basically, what are the things I need? So basically, if you can just write the y bar formula, 1 by capital N summation of 1 by n fi into yi. So I need this number and I need this number, summation, for the summation purpose. I need this number. So how much I'm getting? This is, if we add this number, we will get a 78.5 minus 78.5 as a negative number. Okay? So my y bar would be minus 78.5 divided by 200. 200 is nothing but the summation of the total frequency, right? So this is your y bar. Now I got the y bar, but problem is not on the y bar. I need to find out the x bar, right? So what are the changes I have done here? I have changes this y is equal to this thing. Y is equal to x minus 27 by 5. So let's write that y is equal to x minus 27 by 5. Right? So if I take the individually, so y bar should be x bar minus 27. If I just think in terms of the change of origin, and for change of scale, just divided by 5 should be there, because y bar is equal to x bar by d if y is equal to x by d. So typically I can write like this: if is y is equal to x minus c by d, that means that y bar is equal to x bar minus c by d. If this is possible, so again c can be plus, d can be multiplication, either way. So eventually I got this equation. Now in this equation, what I know the y bar. What I need to find out? X bar. So let's put the values. So let's first simplify this. The x bar should be 27 5 into y bar. Perfect. Now let's put the values. 27 plus 5 multiplied by, please make sure you have 78.5 minus. So do not forget the minus part. And if you solve this, it becomes 25.4. So this is the mean value. And given that you got a big tables and all, this is the process how you should calculate the mean, arithmetic mean for any case. So again, for this case, you do not need to find out any boundary or something. You need to find out the mid value of the class marks, and from the class marks are basically like a representative of a class class intervals. So it may be the class marks are, I mean, it need not to be all these classes as continuous class. If it is not continuous class, even in terms of the class intervals, that is still valid in terms of the finding out the mean or weighted mean in any cases. Now the last thing about, suppose you got a, say, classes. Suppose, say, I got a here, say, two divisions, like division A, division B. Division A is getting the n number of student, n1 number of students are there, and they are getting the x1 number of mean for some subjects, say business statistics. Division B is there, say you got a n2 number of students and their mean is x2 bar. Now if somebody asks you to give the composite mean of the whole class, then how should I find out? So it generally gives us the composite mean is the x bar, then the n of x bar, that n of course is nothing but the n1 plus n2, and the numbers is generally given by n1 plus x1 bar plus n2 plus x2 bar. So just remember this two. Just a small problem, since we have talked about this, explains that. So say number of employee and the mean salary, right? So number of employees given as, say, I do not know number of employees, do not know. Say n1 n2, we have no idea. Amount of salary, mean salary is, say, 520 and 420. So what is the employee ratio? N1 by n2 they are asking for. So ratio is equal to, I'm using the same formula. So okay, total number of employees should be known. So total number of employees, that is a total average salary is 500. That's what I want to know. So in what is the formula? N into x bar, n1 into x1 bar plus n2 into x2 bar. This n is nothing but n1 plus n2 of the x bar, n1 into x1 bar plus n2 into x2 bar. Put the value n1 plus n2 we do not know, but we know the average salary is 500. This we know, n1 into 520 and n2 into 420. Right? Now, of course, we are a little bit algebra. So 80 into 20 n1. So n1 by n2 should be 80 by 20, it is 4 by 1, 4 to 1 is the ratio. Like this, simple problems. If this is all about the mean. Okay, we mostly have covered the mean, how we come to calculate the mean, how we should um, deal with the change in the origin, all these things. Right. So this is the basis of mean. I guess more or less you know all these things, but just to give you a brief idea. So this is the mean, and okay, fine. So from next class, we'll start with the medium. Okay. So if you have any questions, queries, please ask. No questions? Okay, anyway, I'll provide you the mail.
Could you please share the notes?
Yeah, I'll share the handwritten notes after I think whenever I'll share the assignment. Say assignment one is for say with the mean, median, and the correlation regression. So that part I'll share with the notes as well as the assignment that I'll share.
Okay.
So in any case, other cases, if you have any kind of queries, anything, so please mail me. So you know the my email ID.
Okay,
So
sure.
it's scishendu@scit.edu. So you can mail me. So yeah, and again, any other thing you want me to discuss during the future classes, like any specific topic, please let me know. So otherwise, we can stop it today. Thank you all.
Nishant sir, could you please share the recordings of this lecture? Nishant, are you there?
Yes, I'll share.
Okay, thank you so much. Okay, thank you, sir. Thank you so much for your
Okay, thank you.
lectures. Yeah.
So stop for today.
Thank you,
Thank you,
sir.
sir. Okay, sir.
Thank you, sir.
Thank you.
Thank you.